And just like that, I'm back with a microphone. So we're going to have all kinds of noise and buzzing in the background. I apologize. The fan on this radio is very loud. Um, so let's go through here, and we're going to go through the power setup. Let's go back down here to screen cap, and why not? Let's just add us picture of me. I don't know how well that's going to work out. I don't know if you guys can see that or not, but hey, that's what we're going to do. All right, so and I haven't practiced this. We'll just go right through it. So this is looking for the 5 watt, 12 watt configuration here. Um, okay, power low. Swap over here to the A side. Okay, now it's on there. It says, all right, so for 1, 2, and 3, switch to adjustment mode and carry out operations for item C. See the deviation. Oh, okay, transmission output power. All right, so we're looking for APC, which is what we're on. Okay. Frequency 1, frequency 2, frequency 3. Yep, we see that. And, okay. All right, so now I understand what we're doing here. Okay, don't care about transmit frequency adjust. Um, okay, 146. All right. So it's saying 146 even. Be on. All right. It's saying encoder is the frequency 2 key. All right. Let's do that. 46 even. All right. Quiet that guy down. Going like 6 watts there. For 5.5 watts low. That looks good. All right. I'm not sure what adjusts that. How does one adjust that? Um, oh, oh, now I see. Now I see. That's 5 watts. Yes, that's 5 watts right there. Okay. I want to go back up here and reread what it says in the narrative. I think that may have better information. Transmitter power output, select APC. Select the desired transmission output range, high, mid, or low. It's a low key. There we go. Low, 5 watts. Connect the power meter to the antenna connector. All right. Lower limit frequency transmit output setting. Set the lower frequency and press the microphone. So we went all the way to 444 even. So that's our lower limit. It's frequency 1. All right. Okay. And then our upper limit would be so about the same. So those are all the same all the way across. BA, BA, BA. Okay. All right. Okay. And then high. Um, okay. I'm not sure how we're supposed to change that. What we do to change this. By turning the encoder. Oh. Ah. Okay, you can't see that over here on my meter, but yeah, so 50, 60, almost 70 watts there. High. Oh, over temp. All right. So, yep, all right. Frequency 3 will do that. Yep. Yeah, that's just not a big deal. It was totally not a big deal. what are the wattage ratings it wants here? Now that I understand what we're doing, 5 watts, 12 watts, 48 watts or more. Okay, so this midsection should be 12 watts. All right, there we go. That is about 12 watts right there. AO. So that's our lower frequency. 4 megahertz. Also 12 watts. Also 12 watts. All right, so there we go. So low, medium, or high, and medium. They're all set now. Okay, so we're good to go. All of those are set the way that they should be. All right, and then we got to do the same thing on the B band. So, B band. There we go. Birdie sitting there. So we are on high. Let's start on low. It says that we should expect 5 watts. Almost 5 watts, not quite. That works. I'm not even going to go through all that nonsense again. I'll tell you what, before we do that, $5 watts, yeah. I ain't going through all that nonsense. There does not appear to be any changes across the band as far as power output goes into this dummy load. I'm not going to do it. So, all right, so we've got that set across all of those guys. Then let's go to medium power. Medium power is looking like about almost 30 watts here. And it is showing 12 watts. So let's go ahead and bring it on down. 12 watts. Okay. And then go to high power. Oh, man, that's bad. 5 watts. No watts. That's bad. Medium power has power. Low power has power. High power does not have power. Oh, there we go. It was beyond. Wow, look at that. Overcurrent protection or something. Okay. Who knew? So high power supposed to be 33 watts or more. That's about 33 watts. Well, I'm glad I looked at that. That's interesting. All right, now, since we have such a large deviation, I'm going to go across my band here. And make sure everybody's happy. All right, that's right. Okay. All right. Well, I'm glad I did that and validated those outputs are right because it was going into an overcurrent situation. Good to know. All right. We're on 13.8 volts input, so that's good. All right. So power's done. Next thing we got to do is deviation. Oh Lord. Okay, we're going to go band A. Maximum deviation. All right, it's saying do it on 146. 146 even. 5. Test, test, test. Test, 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 test. Test, test, test. Test, test, test. 555. This is not good. Nope. For some reason, my FM. Test, test, test. 1, 2, 1, 2. And yeah, okay, so I got a problem. Test, test, test. I believe I have a problem with my monitor. Test, test, test. 1, 2, 3, 4. Test, test, test. 1, 2, 3, 4. Test, test, test. 1, 2, 3, 4. I have no audio at all. Test, test, test. 1, 2, 3, 4. Nope, I got nothing. Oh, yeah. I just noticed it's got an offset there. All right. So I was transmitting 600 kilohertz off. Yeah. That kind of happens when you do that. Okay. All right. Look at that. We got our plus and minus 5 right there on the scope. Yeah, 1, 2, 3, 4, 5, 5, 5, 5. All right, 5. And we're getting about almost 4 kcs of deviation. Hey, and that's what it's looking for. It's 4.2. 5, 5. Yep. Okay. So yeah, we're getting like 4.2 kcs of deviation. Five, 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 five. 1, 2, 3, 4, 5, 5. Oh, look at that! Woo! Woo! 6. We're getting 6 and 7 kcs of deviation. 5, 6. You know what? These things are notoriously quiet. I'm gonna give myself 5. There we go. Maximum 5 kcs of deviation. 1, 2, 3, 4, 5. 5. 5. 1, 2, 3, 4, 5. And hopefully that will be appropriate these days. I can see some of the waveform going over. Maybe that's not appropriate. 5. 5. There we go, right at it. Okay, 5. That's better. Okay, so we'll go with that. So, yep, doing a little more than it calls for. This is amateur radio. I want a little loudness. Okay, so this next thing is looking for audio. Well, I mean, all of these are looking for input from a signal generator. I'm not doing that. I'm doing this old school. All right. Oh, I didn't set it. I'm an idiot. 5, 5. 1, 2, 3, 4, 5. You gotta be kidding me. All right. 1, 2, 3, 4, 5, 5, 5, 5, 5, 5, 5, 5, 5. 5, 5, 5. I'm screaming into it. 5, 5 kcs of deviation. Okay, there we go. We're going to go with that. 1, 2, 3, 4, 5, 5, 5, 5. 5 by 5. All right. We'll set that. Okay. There we go. Probably going to go back and look at the video and make sure that we did that correctly as far as that's close to what I had before. All right, so now we're going to be doing we'll even, let's go with that. One, two, three, four, 5. 1, 2, 3, 4, 5. Oh, There you go. Well, that's problematic. One of the problems that I have with this thing is it will not lock on UHF in the presence of strong signals. Uh, Junk. Uh, uh, Once is adjustment, twice is abuse. Come on. Well, that's disappointing. I'm going to have to go through that thing and fix it. So, in the absence of that, I am going to adjust this to A5. Just like it is on the other band. Which is a long way from FF, which is where it was set. Wide open. Okay. The service monitor has served me well for almost 20 years. Maybe time for it to go. All right. Yep, it just will not lock. I'm going to assume the deviation's fine. Yeah. Probably tune it in with another radio. I can do that right here. Band 430. FM 444 even. Go. Test, 1, 2, 3. Test, 1, 2, 3. 5. I have a band scope. 5, 5, 1, 2, 3, 4, 5, 5, 5, 5, 5, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Okay. There we go. 1, 2, 3, 4, 5. Yep. Audio sounds good. 1, 2, 3, 4, 5, 5, 5, 5, 5 by 5. 1, 2, 3, 4, 5, 5. Yep. We're good. Okay. I think we're good there. All right. So deviation set. And so now we got to set our DCS balance. I don't know if we're going to be able to do this on UHF or not. DCS balance. Okay, there we go. Five. Okay. And there may be no way that I can do that with this. I may have to actually connect the DMOD up to an external scope. Wow. Now my scope is not working. There it is. It's off just a little bit. So the way you're supposed to tune and encode or adjust the modulation wave until it becomes the square wave. Well, it is the square wave. Yeah, it is the square wave. We can. Oh, okay. As I'm adjusting it, I'm seeing the edges of it changing. Yeah, that's pretty good right there. Yep. She's a square wave now. we are set. Do that on the other side. And of course I can't set it because I can't receive. What I can do is set it the same. There we go. It ought to be good enough for government. Okay, so we've got that set. Now we get to do tone deviation. And that's looking like 0.05. Should be 0.8. So turn up just a little bit. Oh, wow. All right, there we go. Yeah, we're a solid 0.8. That's what it looks like on the scope. It looks like a 0.8. So we'll go ahead and set that. And I'm going to do that same level on this side. Hey, I wonder if I can do, if I get a harmonic work. Hello? Hello? No, that didn't work. I tried. Okay, so we've set those levels. Oh, we've got to do it on the other bands. Good Lord. Well, it's the same across all of them. What does it matter? Yep, that's settling in 0.8. I'm good with it. And yeah, let's see, what's the tone? Sub-audible tone. 88.5. And yeah, 88.5. Yeah, it's generating the correct frequency. All that's good. We already did DCS deviation. Oh, no, we didn't. We just were setting the flat tops on the DCS, not the deviation. All right, so DCS deviation. All right, let's go through with that. It's a bit loud. Saying 0.8, but yeah, that's a bit high. There we go. All right, we'll go with that. That one also high. All right, there we go. Okay, all right. Looking good. And yay, that's it. We have now done, as best I could do, an alignment of this radio. So, so one of the problems that you run into is you have to make sure that your all of your deviations set correctly, appropriately. I didn't go through the full technical thing. Typically, you yell into that microphone as loud as you can, and as long as you're within 5 kcs, occupying 5 kcs of bandwidth, you're okay. Man, I really wished my service monitor over here worked on UHF. So I'm gonna have to get that thing either repaired, or if any of you out there happen to have an IFR, let me know. I've wanted one of those for almost 30 years now. Yeah, these radios are cool little things. Anytime you reset the do a full reset on them, or change out the EEPROM, you got to go through this alignment procedure. And if you don't, your tone levels are wrong, your deviation is wrong, your power levels are wrong, and as you saw, by default, it wouldn't even transmit on UHF. You know, it's going in an overcurrent condition. The signal, yeah, your estimators are going to be all out of whack, and that's the first thing you notice. And your squelch controls don't work the way they're supposed to. So you have to go through this alignment. Let me show you a couple of things here. I'm just going to grab my camera and hope that I can show these to you. Pull the camera off of my mount right here. There we go. That is what I had to do right there. If you can see that, I don't know if we can get it to focus correctly. Number 6 and number 3, you got to short those out in order to get it into that mode. And that is what the service monitor looks like. It is a POS, fortunately. So there we go. And that is going to conclude this episode of Terry's Workbench. So you get to laugh and make fun of me because I just stumbled through this thing as best I could. I hope you enjoyed the video, and we will talk to you later. Bye.